Welcome to the deep dive. So today we're doing something pretty specific.
Yeah.
We're looking at the tech specs for this WolfPack 4K 30Hz HDMI splitter. It's a 1x4 unit with EDID management.
Okay, the HDTV SPL 4K330104.
It's got it. Exactly. And it's only about $50, which is interesting. Its main job is simple, right? Take one HDMI in, send it to 4 screens simultaneously.
Pretty standard stuff.
But the thing is, its bandwidth is capped at 10.2 gigabits per second. And that low ceiling, well, it forces some, let's say, interesting choices.
That 10.2 GBPs is definitely the key constraint here. It governs everything else.
So our mission today is basically to decode what that limit means, break down the jargon like 4.2.0, EDID, all that stuff, so you know what you're actually getting.
And it is HDCP 1.4 compliant.
Yeah.
It does support resolutions up to 4K, specifically 4K 2K at 50 or 60 hertz.
Okay, but there's a catch with that 60 hertz, isn't there, because of the bandwidth?
Exactly. That's the fine print people miss.
Yeah.
To hit 4K at 60 frames per second, you have to use the YCBCR 4.2.0 color space.
Okay, let's unpack 4.2.0 a bit. For someone maybe learning this stuff, what does that compression actually look like? Are we losing, like, subtle color detail?
Yeah, mostly. Think about smooth gradients in a sky or large areas of similar color. 4.2.0 basically uses less data for the color information compared to the brightness.
So it's like keeping the sharpness, but maybe sacrificing some color richness to hit that speed?
Sort of. The detail in, say, sharp text usually holds up okay. But those smooth color transitions might show some banding or look a little less vibrant.
And if you want the full uncompressed color, the 4.4.4 space.
Then you have to drop the frame rate. You can get 4K at 30 hertz with full 4.4.4 color. That's the trade-off imposed by the 10.2 GBPs limit.
Which is a pretty significant choice depending on what you're watching or doing.
Absolutely.
Now, what's really throwing me looking at the source material is the mention of HDR support. HDR10, HDR10 plus even Dolby Vision. Dolby Vision especially, that's known for being beta heavy. How does this splitter handle that on just 10.2 GBPs?
Well, it handles it by negotiating. The splitter can pass the metadata, it understands the format, but to actually transmit it within that limited bandwidth, especially at higher frame rates like 60 hertz.
It's likely using that compressed 4.2.0 pathway again.
Almost certainly. Or potentially dropping other parameters. The key is the feature is supported, but the quality you get is dictated by that bandwidth ceiling.
Gotcha. So it passes the signal, but maybe not in its absolute highest fidelity form.
Correct. What's interesting, though, is the audio side doesn't seem to face the same squeeze.
Ah, right. The specs mention some pretty serious audio formats.
Yeah, high-fidelity stuff. DTS HD, Master Audio, Dolby True HD, LPCM 7.1, even DSD.
DSD. Wow. Okay, so that's like super audio CD quality.
Yeah.
Serious audiophile territory.
Exactly. So while the video signal is kind of tightly managed due to bandwidth, the audio path seems, well, pretty robust.
That's good to know. But even with great audio and video potential, if the devices can't talk to each other properly, nothing works. Which brings us to EDID.
Ah, yes. EDD management, the source of much frustration in AV setups. That extended display identification data.
The handshake where the display tells the source what it can handle, right?
Precisely. And this splitter has built-in management to hopefully prevent those no-signal nightmares. It gives you 2 modes via a little switch on the panel.
Okay, what are they?
First is STD mode, standard mode. Think of it as the universal fallback. It forces a fixed default output, 1080p at 60 hertz with 2-channel audio.
So, guaranteed picture, even if it's basic. A safe bet.
Right. It ensures something shows up on all 4 screens, regardless of what they are.
And the other mode, for when you want more, maybe with matching displays?
That's TV mode. In this mode, the splitter reads the EDID information only from the device connected to HDMI OT1.
Ah, so it clones the capabilities of display number 1.
Exactly. Copies that EDID and tells the source device to send that specific signal, which then gets sent to all 4 outputs. Great for ensuring sync if you have 4 identical, at least very similar displays.
And what if nothing's plugged into OUT1, or it can't read the EDID?
Smart question. It defaults back to the safe setting 1080p 60 hertz 2-channel, so you're never completely stuck without a signal.
That EDID handling alone seems pretty valuable for a $50 box. The source also mentions it installs quickly and has a metal enclosure.
Yeah, the metal housing is nice. And inside that box, there's signal retiming circuitry.
What does that do for you?
Stability, mainly. It cleans up and reclocks the HDMI signal. This actually lets you cascade these splitters, connect the output of one to the input of another.
Oh, interesting. So you could go 1x4, then feed one of those outputs into another 1x4 to get, what, 1x7 total?
Or even more. The specs say you can cascade up to 3 layers deep, but there's a catch again?
Let me guess. Bandwidth related.
You got it. That cascading is really only reliable for full HD 1080p signals. The unit just doesn't have the horsepower to reliably retime and repeat a high-bandwidth 4K signal through multiple stages.
Right, makes sense. Stability also often comes down to cables. How far can you actually run the HDMI cables with this thing?
Good point. Cable length is often overlooked. For the input cable going into the splitter, the spec says up to about 30 feet, using AWG22 or AWG24 wire.
And on the outputs, going out to the displays.
Because of that signal retiming, you can actually push a bit further on the output side. Up to 50 feet is claimed.
50 feet? That's pretty decent.
Yeah, but they recommend using a thicker AWG22 cable for those longer output runs to maintain signal integrity, especially closer to that 50-foot limit.
Okay, so summing this up for you, the listener, you've got this $50 splitter. It supports impressive formats like Dolby Vision, has great audio handling, decent EDD management.
It's fundamentally constrained by that 10.2 Gbps bandwidth.
Right. And you have these practical cable limits, 30 feet in, 50 feet out. So the final thought, the thing to really consider is this. When you're pushing a complex format, say Dolby Vision, over a potentially long cable run, like close to that 50 feet, what's the better compromise forced by that 10.2 Gbps limit? Do you drop to 4K 30 Hz to keep the full 4.4.4 color fidelity?
Or do you push for 4K 60 Hz, accept the 4.2 point EO color compression, and just hope that long cable run holds the signal stable?
It's a choice this specific piece of hardware forces you to make. You're actively managing that balance between frame rate, color accuracy, and distance, something to really think about.